Hello friends, this video on direct and inverse proportion part 5 is brought to you by examfear.com. No more fear from exam. Hello friends, this video on direct and inverse proportion part 11 is brought to you by examfear.com. No more fear from exam. So this was all about direct proportion. Let us now talk about inverse proportion. So now that we have learned about direct proportion, we will know more about inverse proportion. So the name itself tells us that it is something which is exactly inverse of what we have learned in direct proportion. So here you see a birthday cake for a birthday party. Okay, now let's say that 8 of your friends reach at your birthday party and now you need to give them cake. So what do? You divide this cake into 8 equal slices and give each slice of cake to each of them, right? Now let's say that you invited a lot of friends. Now instead of 8, some 16 friends arrived at the party. So what will you do? Because you still have just one birthday cake. So what do? This time you divide the cake into 16 equal slices so that you can give one slice to each. Now in this case we notice something. We see that in case 2 the number of people increased, number of children increased. As a result, what happened? The size of each slice decreased. So right now each slice is smaller, whereas in the previous case each slice was bigger. So this shows that the size of the slice is inversely proportional to the number of kids. So as the number of kids increases, the size of the slice decreases. So this is an inverse relationship. Let's take one more example. So let's say that you have to decorate a room for your friend's birthday. Now there are 3 scenarios. In the first scenario, you do it alone. So you do all the decoration alone and it takes you 2 hours. In the second scenario, you take help of another friend and 2 of you do it together and it takes you 1 hour. In the third scenario, you call few other friends and the 4 of you together do it, and that time you take 15 to 20 minutes for the same decoration. So what does this show? This shows that when the number of people involved or the number of people who are working for the decoration that increases, then the time taken to decorate decreases. So here also the time taken is inversely proportional to the number of people involved in decoration. So these are some examples of inverse proportion. Now let us talk about speed and time. So we have spoken about distance, time and speed before also. So this time we assume that the distance is fixed. So let's say that we know that the car has to travel from point A to point B. So this is the fixed distance. So if the distance is fixed, how speed and time would vary? So let's say in the first scenario, the car travels with a very high speed. So in this case, the time taken by the car to travel from A to B is maybe very small, maybe some 5 minutes. So this is our case 1. So in case 1, we say that the speed of the car, let us assume that the speed of the car is 24 kilometers per hour. And the time taken by the car to travel this distance AB is 5 minutes. So 5 minutes is 5 by 60 hours. That is 1 by 12 hours. Perfect? Okay. Now let's consider case 2 where the car is traveling with a lesser speed. So this time in case 2, the value of speed is 2 km per hour. Now since the speed is lesser, the car is moving slowly, therefore the time taken is more. So this time, the time taken to cover the same distance AB is 1 hour. So what's happening here? In this case, we see that if distance is same, if speed increases, time decreases. If speed decreases, time increases. So there is an inverse proportion relationship between speed and time provided distance is fixed. So looking at this, what can we say? We can say that in this case, if you look at case 1, you see speed into time is equal to 24 into 1 by 12, which is equal to 2 kilometers. In the second case also, speed into time is equal to 2 into 1, which is equal to 2 kilometers. So basically we see that the value of speed into time is same in both the cases. So this is another example which shows that speed and time are inversely proportional to each other. As speed, higher the speed, lesser the time, lesser the speed, higher the time, provided distance is fixed. So what is inverse proportion? So when two quantities x and y are said to be in inverse proportion if x into y is equal to k. So in this case, the ratio doesn't remain constant. Instead, the product of the two quantities remain constant. So let us take the same example as we took in the previous. So we saw that in case 1, the speed of the car was 24 km per hour, and in this case time taken was 1 by 12 hour. And in case number 2, speed of the car was 2 kilometers per hour and time taken was 1 hour. So these were the two scenarios that we considered. So what are the two quantities involved? Speed and time. So let us say speed is the variable x and time is, let's say, t. So just assume that these are two different quantities, x and t. So in this case, what do we see? Let's assume this value as x1, this value as t1, this value as x2, and this corresponding value as t2. So we very clearly observe that x1 t1 is equal to 24 into 1 by 12, which is 2 kilometer, and x2 t2 is equal to 2 into 1, which is equal to 2 kilometers again. So from this we see that x1 t1 is equal to x2 t2. That means at all instants of time, the product of these two quantities will always be constant. So therefore, if x and y are in inverse proportion, we can write that x1 y1 is equal to x2 y2 is equal to k. So this is the concept of inverse proportion. Now let us. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.